You're listening to Geoversity Podcast. I'm Brad Hillis, the editor of Geoversity. A layman's talk is an important part of a PhD candidate's defense of their thesis. It's usually a talk of about 10 to 15 minutes, and it presents the essence of a candidate's research in an accessible way that family and friends in attendance can understand. For this ongoing series, we're inviting PhD candidates who are either about to graduate or who've recently defended their theses to come in and deliver their layman's talk. My next guest is Andhika Ariyanto, who came in to tell us about his research on using spatial data science in the conservation of the Javan leopard.
Well, my thesis entitled Spatially Explicit Conservation of the Javan Leopards in Human-Dominated Landscapes. I would like to begin with a question that has guided this entire thesis. How does a large carnivore, one that requires vast home range to survive, but still persists on the world's most densely populated islands? So the general objectives of this thesis is both to understand this phenomenon ecologically and to translate that understanding into policy and practical conservation management. But before entering the science, let me give you an illustration of how crowded Java Island as the study area is. Well, Java is roughly 3 times the size of the Netherlands, and it is about 8 times the population of the Netherlands. At the same time, it remains an important refuge for high levels of biodiversity, including the endemic Javan leopards. This raises 2 urgent questions. Why should we protect this predator, and how can its conservation be achieved in landscape undergoing rapid human transformation? Large carnivores are vital to ecosystem functioning. As an apex predator, they regulate herbivore and mesopredator populations, thereby stabilizing trophic interactions and maintaining vegetation structure. When an apex predator declines, ecosystems often experience trophic cascades. There will be overbrowsing, soil compaction, degraded vegetation, and ultimately reduced ecosystem services. Therefore, protecting top predator is not only about saving a species, but also about maintaining ecological resilience of landscapes that sustain human communities. To address the previous questions, this thesis comprises 4 consecutive studies. And there are 4 keywords that organize the storyline. First, prey identification. Second, prey distribution models. Third, leopards distribution models. And the last, habitat connectivity. And these are the results. First, using camera traps across 4 national parks representing terrestrial ecoregions, we documented 2 key patterns. First, areas with leopards presence consistently exhibited higher species richness and abundance than areas without leopards. And second, based on spatio-temporal analysis of camera traps images, we identified 10 species whose activity patterns most strongly overlapped with those of the leopards in time and space. Such co-occurrence is a recognized proxy for predator-prey interaction. Therefore, we treated this species as a potential candidate prey for the Javan leopards, and this is the foundation for everything that follows. This study highlights that conserving diverse prey communities is essential for maintaining viable leopards populations in fragmented tropical landscapes. Second, having listed the potential candidate prey for the leopards, we modeled the distributions of 8 potential candidate prey species using ensemble species distribution models. Predictors included environmental conditions such as temperature, rainfall, distance to forests, distance to settlements, and other anthropogenic variables. The research shows that the distance to primary and secondary forests emerged as the most influential predictor. And when we stack these prey distributions to generate what we call as prey hotspot map and overlay them with known leopards occurrences, we found that more than 94% of leopards occurrences overlapped with areas supporting 5 or more prey species. It highlights that areas with elevated prey diversity may serve as a key indicators of potential core habitats for these carnivores. Third, after we have the prey distribution maps, we model Javan leopards distribution models incorporating prey distribution as a predictor variables alongside environmental and anthropogenic variables. And based on several scenarios, the result shows that including prey distribution measurably improve the predictive accuracy of leopards' habitat models. And the two strongest predictors were prey richness distribution and distance to secondary forests. The central message of this study is clear. Protecting leopards' habitat without securing prey populations is ecologically insufficient. Therefore, habitat and prey must be managed together. And lastly, given the suitable habitat of the Javan leopards in the third study, the fourth study modeled potential structural corridors to link the habitat patches using least cost path and circuit theory framework. These are two complementary methods that map the routes of a species to move between isolated habitat across human-modified landscapes. In this study, we compared two scenarios, a baseline and a reforestation scenario. The baseline included planned and existing major highways and railways in the resistance layer, and the reforestation scenario incorporated baseline plus government's forest rehabilitation plan. And what the result shows, under the reforestation scenario, two corridor quality indicators both decreased. The indicators we used were the ratio of accumulated cost-weighted distance to Euclidean distance and to least cost path distance. Decreasing ratios indicate straighter and lower resistant pathways between habitat patches. It is a measurable improvement in structural connectivity. Therefore, this study demonstrates that strategically located reforestation partially restores connectivity and may serve as an early indicator of functional recovery. It translates a government forest rehabilitation plan into spatially explicit conservation evidence. So, how do these four studies answer the previous questions? The studies argue that the persistence of Javan leopards on such a crowded islands is determined by prey-based availability and forest structure, and also with the need for future habitat connectivity to assure its long-term survival. Additionally, this thesis contributes to conservation science in three specific ways. First, it provides the first island-wide spatially explicit assessment of prey richness as a fundamental driver of the Javan leopard's distributions. Second, it quantifies the functional importance of secondary forests as both habitat and movement substrates in a fragmented landscape. And third, it reframes reforestation as a spatially explicit and measurable indicator of restored connectivity rather than an abstract conservation aspiration. And as final reflection, how can we translate this finding into policy and practical conservation management? First, the spatial explicit result of this study can be one of the consideration of land use planning, such as the strategic environmental assessment process, as well as in islands of provincial levels, in this case Java, spatial plans. Second, for practical conservation management, it serves as a foundation for the renewal of the strategy and action plan for the Javan leopards and other species, and guiding the forest rehabilitation plan and infrastructure setting. And more broadly, this thesis contributes to growing international efforts to understand how wildlife and humans can continue sharing landscapes in the Anthropocene. And hopefully, living with predators in human landscapes is no longer a paradox. It is the essence of coexistence. Thank you.
Thanks for listening to Geoversity Podcast. Join us again in future for more layman's talks from PhD candidates from the ITC faculty, as well as other faculties at the University of Twente. And if you'd like to explore more content that makes scientific research accessible, check out our website geoversity.io.